Now we would like to program a program for solving or finding a solution for three equations in as application of linear algebra. So we have a good example in physics in Kirchhoff laws in electricity to find the three unknown currents in these three resistances I1, I2, and I3. So I have here three unknowns. I need three equations to solve this unknown. So I using Kirchhoff law, we prepare these three equations. So the first equation I1 plus I2 plus I3 equals 0 and so on for the second and three equation. So I have here two arrays, array of unknowns and the array of solutions. Let's go to the other slide. So this is the example. The array of solutions is A, and these are the coefficient 2, 1, 1, 2 times A and 1 times B and 1 times C, and so on with the other equation and the third equation. The second array is the unknowns A with B with C, and the third is the solution, the array of solutions, the 4, 5, 6. Okay, so unknowns X matrix or X array equals A exponential to minus 1, the matrix A minus 1 times matrix B. So let us write the program to solving this uh, uh, first we will NumPy. Let's write import NumPy as NB. Okay, NumPy as NB. What we are doing here? Define matrix A, matrix A, matrix A, matrix A using NumPy, using NumPy. Okay, arrays. And this is a comment because of this we started with the hashtag. Matrix A equals NB dot array dot, when we press dot, all the functions inside the library NumPy appears. We need array. Fine with me array. This is the function we need. So open the parentheses of the function and put the argument. The first row or the first equation. This is the first. 2, 1, 1. From where I get this? From here. From here. 2, 1, 1. Okay, this equation. Let's go back. Huh. Then the second equation in another list, which also brackets 1, 3, 2, and at last the third coefficient of the third equation, 1, 0, 0. The matrix A. Define matrix A. This is A define matrix, define matrix. Here, I'll copy this one, Control C, and here, and change this to B. Okay, okay. B equals the same, NB dot A, and matrix B. What's the arguments of matrix B? Matrix as the solution. Matrix B, which is the 4, 5, 6. So we write here 4, 5, and 6. Oh, but have to input brackets, okay, and close with bracket. And now we need using line dot solve and function, line algebra dot solve, another function dot solve. Okay, type. Let's say find print, and here solutions, and put it in another line, mhm, quotation, and we have comma NB and dot. So when we press dot, we get the function inside the NumPy, which is here is NB, because NumPy has NB, but as NB. We need function called uh, line algebra. We press L I, it's line algebra, and then dot, another dot. Also, the function line algebra has many functions, which we need is the solve. Press SO, we get it solve, this one, okay? And we open the argument, and we have the argument here is the matrix A and matrix B. We have matrix A in capital and matrix B, okay? Now we're ready to operate this one. Here there is some error. Here we may put all this in parentheses, I think. Try. Let's now try to run the program, run from here, and check to see. Oh, let's see here, clear this variable. I the other, the new ones for this program, this for old program. And now to run, save it, solving, solving, and the equation as 3, or linear, solving linear equations. Mm. Okay. Now, yes, I think it run. Now it run. Value error. Only two non-keywords arguments accepted. Here's some error. There is some error here. Line 10. We have some saying in line 10. This one. Uh, Maybe here there is something. Uh, let's try again. Uh, Only two non-keywords arguments. Only two non-keywords arguments. This is maybe. uh, here bracket here, here. No bracket, not curly, but it's type this curly. Yes. Run now. Yes, now it's okay. This is the solutions for the three. This is the three unknown 6 and 15 and minus 23 for these equations. For these equations, we found the A, B, and C. So A, B, and C is equal to this solution. A and B and C. A equals 6 and B equals 15 and C equals minus 23. Thanks for listening.